All right, this video is for Learning Target 6. There will be 3 videos because Learning Target 6 is solving real-world problems, and there's going to be 3 distinct types. The first video is for mixture problems. Mixture problems can be done a couple of ways. I'm going to do them with a method uh, like weighted averages. The other type of word problem is distance problems, and there'll be a second video for that type. And then the third and final will be work rate problems. So this is the first video in a 3-part series. The first thing with doing a mixture problem is we're going to do weighted averages. So in class, I needed to make sure we remember how to do weighted averages. So we did this prompt. So if you want to pause the video for a second and try it yourself, the prompt is simply, here is an Algebra 2 student's grades for a unit. What is their grade in the class? Because we use a weighted average of 20% homework, 30% quiz, and 50% test. So if you want to pause the video and try that, or continue, and I'm going to work it now. The homework points, you get 100%. According to this, they have 100%. So you get 20% of those 100 points you earned from the homework. So 0.2 times 100 represents the amount of points you received from homework. The quiz is 85%. The student made 60s on the quizzes, but they corrected on, finished their Math Excel, so their quiz grade ended up being 85. So of those 85 points, they actually earned 30%. So 0.3 times 85. And then finally, their test average was an 80, and it counts 50%, so they earned 50% of those 80 points. So 0.5 times 80. And if you add up the points that they earned, you'll get the final average for that student during that unit. And that average is 85.5%, which would round up to an 86% B. So the subliminal message here is do your homework, fix your quizzes, do your Math Excel, and the rest will take care of itself. And I know those are easy things to say, but they are also vital to success in the class. But the important part, weighted average. 20% of this, 30% of this, 50% of this. So now let's apply that to our first problem. The weighted average the weighted average method that I'm going to teach is different than the Green Book's method. So if you would like to look on page 596 in your Green Book, you will see the same problem worked completely different, except the table will be set up much the same, except one box. The box right here will be different than what the book sets up because they're going to use a different method. So, all right, here we go. Mia adds 70% acid solution. So she's adding a 70% solution to 12 milliliters of a solution that's 15% acid. So the original solution is 15% acid, and furthermore, it has 12 milliliters. Continuing to read, how much of the 70% acid should be added to create a 60% acid solution? So we're trying to create a 60% solution. Well, if we're going to create a 60% solution, it's going to take a lot of the 70% to get it there. A lot meaning a lot more. Sorry about that. A lot meaning a lot more than 12 milliliters, because 60% is really close to 70%. And if you're going to be adding a 70% solution to a 15%, it's going to take a lot of that solution to get it up to 60% in the end. So with that in mind, that's all that we were given. But we have enough information to finish the rest. The total amount of solution. This table helps us organize all the information. Well, the total amount of solution we're going to add, we don't know. So X milliliters, we don't know how much of that 70% we're going to add. But if we pretend for a moment that we add 50 milliliters, how much will be in the solution once we've finished adding the two together? Well, we'd have 50 plus 12. We'd have 62 in this spot here. Well, since we don't know, we can still express that total amount in the final mixture as the 12 milliliters that we started with plus the X milliliters that we add. So that completes the bottom row of the table. Now the top row represents the amount of acid. So in the original solution, 15% of the 12 milliliters was acid. So 0.15 times 12 represents the amount of acid in the 12 milliliters. So that would be, I think, 1.8. So 1.8, excuse me, 1.8 of the 12 was actually acid. The rest was probably something else, some kind of filler, water. I don't know. I'm not sure if you would mix water with acid, but some kind of filler. In the 70% solution, I don't know how much actual milliliters was acid, but I know 70% of the solution was acid. So 0.7 times the total amount of solution times x represents the amount of acid. So here's where me and the book are going to differ. The book uses the logic that we used in the bottom row. You can take the 12, you can take the x, and you can add them to get this number. So you could use that same logic and take the top row, 15% times 12. You could take that top row and add them and put that there. And if you do, then you'll need to set that equal to the percent you're looking for, which is 60%, and it creates a fraction, creates a rational equation, and that kind of fits in this unit. It makes sense, but I'm going to back up and do it a different way because I think it's easier the way I'm going to teach it with weighted averages. And the way we're going to fill this last box in is using the same logic we just used in filling out 15% times 12, 70% times x. Your amount of acid in the end should be 60% of the x plus 12. So 60%, 0.6 times 12 plus x. And in doing so, we can now use this logic. The amount of acid that we started with and the amount of acid that we added should equal the amount of acid that's in the final mixture, which is represented by green. So little play on colors there. Yellow plus blue makes green. So 0.15 times 12 plus 0.7 times x, the amount of acid you put together should equal the amount of acid you're wanting to have in the end, which is 60% of the 12 plus x. So that's my method. Again, if you look in the book, it's going to be different, and theirs is going to involve more rational equations, cross multiply. It kind of fits the unit a little bit better, but I just think that this method provides a better approach. So finishing it is just distribute, combine like terms, and solve a problem from probably pre-algebra. So distribute your 0.6, and you would get 7.2. So 7.2 plus 0.6 times x. 0.15 times 12 is 1.8. And given the 0.7x and the 0.6x as options, I got to get them on the same side, so I'm going to subtract the 0.6x, leaving me with a 0.1x. And then knowing my x is on the left side, I'm going to go ahead and subtract the 1.8 to the right side, or from both sides, making it 5.4. And then when you divide by 0.1, you get x equals 54. Does that fit what we opened up saying? And we opened up saying that if I'm going to add a 70% material to a 15% material and achieve a 60%, I'm going to have to add a whole lot of that 70% material to get it up to 60, a lot compared to the original 12. So 54 is a lot compared to the original 12 milliliters, so it does fit the reasonable check. So that is mixture problems that I do with weighted average method. Your homework, which I will pull up here just to explain on this video. Your homework is categorized based on the style of problem. So if you look at the bottom of, there it is. If you look at Learning Target 6, you'll see that there are 4 problems of weighted average, and they all will kind of look like the notes we just took. The table, you'll need to construct your own table for some of these, but that takes care of our weighted average problems.